Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 9 to the power of x is equal to 18. Now the first thing I'm going to do is I'm going to take the log on both sides. So now I have log 9 to the power of x is equal to log 18. Now, an important property of logarithms is that, let's say we have something in the form log a to the power of b. We can actually move this exponent b to the front of the logarithm. So this is going to actually equal b times log a. So I'm going to use this property on log 9 to the power of x. So we can think of 9 as a and x as b. So I'm going to move our x here to the front of the logarithm. So this is going to equal x times log a. So now I have x times log a is equal to, sorry, it's not a, it's 9. So I have x times log 9 is equal to log 18. Now we want to isolate x, obviously. So I'm going to go ahead and divide log 9 on both sides. So now I have x is equal to, because these two cancel out, log 18 over log 9. Now 18 is equal to 9 times 2. So I'm going to rewrite log 18 as log 9 times 2. And now we're dividing this by log 9. So now, if I have a logarithm in the form log a times b, this is actually equal to log a plus log b. Because remember, if you guys already didn't know, when you're adding logarithms, you're technically just multiplying the two numbers in front of the logarithms. So now log 9 times 2, this is going to equal log 9 plus log 2. So now I have log 9 plus log 2 divided by log 9. And now, this is the same thing as log 9 over log 9 plus log 2 over log 9. All I simply did was I divided this into two parts, because remember, if you add these again, you'll simply get log 9 plus log 2 over log 9. So now, log 9 over log 9, these two would cancel out, so this is the same thing as 1. So I have 1 plus log 2 over log 9. Now, log 9, well, 9 is the same thing as 3 squared. So now if I replace 3 squared for 9, I get x is equal to 1 plus log 2 over log 3 squared. Now remember, property of logarithms, that states that if we have something in the form log a to the power of b, we can move our exponent b to the front of the logarithm, so this would equal b times log a. So log 3 squared, that is going to equal, we move the 2 to the front of the logarithm, so we will have 2 times log 3. So now I have x is equal to 1 plus log 2 over 2 log 3. Now log 2, this is equal to approximately 0.301. and log 3. This is equal to approximately 0.4771. So now if I go ahead and substitute in log 2 and log 3 into our original equation, I get x is equal to 1 plus, now log 2 is equal to 0.301, so I have 0.301 over 2 times log 3. Log 3 is equal to 0.4771, so I have 2 times 0.4771. So now I have x is equal to 1 plus 0.301 over 2 times 0.4771. Now let's simplify this. 2 times 0.4771. This is equal to 0.9542. So I have x is equal to 1 plus 0.301 over 0.9542. Now I'm going to go ahead and simplify 0.301 over 0.9542. So this is equal to 0.3154. So 1 plus 0.3514 is simply 1.3154. So x is equal to 1.3154. And now I'm going to give you guys a similar problem, but which is much easier, and it doesn't require any logarithms. So our original problem was 9 to the power of x is equal to 18. Now I'm going to give you guys 9 to the power of x is equal to 27. So I'm going to ask you guys to pause the video and try to solve this problem. Alright, so I'm assuming you guys pause the video and try to solve the problem. So we have 9 to the power of x equals 27, and 9, this is the same thing as 3 squared. So 9 to the power of x, this is going to equal 3 squared to the power of x, which is equal to 27. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 3 to the power of 2 to the power of x, this will equal 3 to the power of 2 times x. 2 times x is simply 2x. So 3 to the power of 2x is equal to 27. Now 27, this is the same thing as 3 to the power of 3. So I have 3 to the power of 2x is equal to 3 to the power of 3. And if I have something in the form a to the power of m is equal to a to the power of n, then this means that m is simply equal to n. Because if both the bases are the same, that means both the exponents are the same as well. So I have 3 to the power of 2x equals 3 to the power of 3, and our exponents are 2x and 3, so I'll set them equal to each other. 2x is equal to 3. Now if I divide both sides by 2, these two cancel out, so I get x is equal to 3 over 2. So this is our answer. And I can even go ahead and plug this in for x and see if it's right. So check. We have 9 to the power of x is equal to 27. X is 3 over 2, so we have 9 to the power of 3 over 2 is equal to 27. Now I can rewrite this as 9 to the power of 3 square root of that, which is equal to 27. Now 9 to the power of 3, well that's 9 times 9 times 9. 9 times 9 is 81, so 81 times 9, which is equal to 729. So now I have the square root of 729 is equal to 27, and the square root of 729 is 27. So if 27 is equal to 27, because this is right, our solution is right. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 4 to the power of x plus 10 to the power of x is equal to 25 to the power of x. Now what I'm first going to do is I'm going to divide both sides by, 4 to the power of x. So then first off, these two cancel out. So I have 1 plus 10 to the power of x over 4 to the power of x is equal to 25 to the power of x over 4 to the power of x. Now, if I have something in the form a to the power of m over b to the power of m, this is the same thing as a over b to the power of m. So for both 10 to the power of x over 4 to the power of x and 25 to the power of x over 4 to the power of x, I can rewrite this as 10 over 4 to the power of x and 25 over 4 to the power of x. Now 10 over 4, this can be simplified to 5 over 2. And 25 over 4, this can be simplified to 25, this is 5 squared, and 4, this is 2 squared. So I have 5 squared over 2 squared to the power of x. Now remember how I said if I have something in the form a to the power of n over over b to the power of m, this is equal to a over b to the power of m. So in this case, I have 5 squared over 2 squared, so we can rewrite that as 5 over 2 squared, and then we have to the power of x. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. And for multiplication, the order doesn't matter, right? Meaning, a to the power of m to the power of n, this is also equal to a to the power of n to the power of m. So 5 over 2 to the power of 2 to the power of x, we can rewrite that as 5 over 2 to the power of x to the power of 2. So we simply switch the order of 2 and x. So now what I'm going to do is I'm going to let u, the variable u, equal 5 over 2 to the power of x. So now if I substitute in u for 5 over 2 to the power of x, I get 1 plus u is equal to u squared. Now I can subtract u and 1 on both sides, so then these two cancel out, and I would have u squared minus u minus 1 is equal to 0. Now I need to plug this in to the quadratic formula, which is, if you didn't already know, negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, the coefficient in front of u squared is 1, this is negative 1, and this is negative 1. So a is equal to 1, b is equal to negative 1, and c is equal to negative 1. So now if I plug this in, I get negative 1 plus or minus the square root of b squared is negative 1 squared minus 4 times a, which is 1, times c, which is negative 1. And I'm dividing this by 2 times a, which is 1. Now if we simplify this, negative 1 is positive 1, plus or minus the square root of negative 1 squared is 1, minus 4 times 1 is 4, 4 times negative 1 is negative 4, all over 2 times 1 is 2. Now this is equal to 1 plus or minus the square root of 1 plus 4, which is 5 over 2. So this gives me two solutions. I have u is equal to 1 plus the square root of 5 over 2, and I have u is equal to 1 minus the square root of 5 over 2. So remember how we stated that u is equal to 5 over 2 to the power of x. So if u is equal to 5 over 2 to the power of x, and I already have two values of u. So let's first try 1 plus square root of 5 over 2 and see what we get. So I'm going to substitute in 5 over 2 to the power of x for u. So now I get 5 over 2 to the power of x is equal to 1 plus the square root of 5 over 2. Now I can take the log on both sides, so I have log 5 over 2 to the power of x is equal to log 1 plus the square root of 5 over 2. So now if I have something in the form log a to the power of b, this is equal to, I can actually move this exponent b to the front. So I'll have b times log a. So log 5 over 2 to the power of x, I can move this exponent to the front. So this will get me to x times log 5 over 2. This is equal to log 1 plus the square root of 5 over 2. So now if I divide log 5 over 2 on both sides, these two cancel out, and I will be left with x is equal to log 1 plus the square root of 5 over 2 over log 5 over 2. Now if I have something in the form log a over b, this is equal to log a minus log b. So log 5 over 2, this is equal to log 5 minus log 2. So now I have log 1 plus the square root of 5 over 2 over log 5 minus log 2. And this is equal to approximately, if you plug this into a calculator, x is equal to 0.525. Now for our other value of u, we have u is equal to 1 minus the square root of 5 over 2. And now if I plug this in, I get u 1 minus the square root of 5 over 2 is equal to 5 over 2 to the power of x. However, this actually is rejected because 1 minus square root of 5, that is a negative number. And you can't take a power of a positive number and make it negative. So this has no solution, meaning our only solution for x is 0.525.